Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 3 to the power of 4 plus n plus 1 to the power of 4 is equal to 82, and we will solve this problem for the value of n. So the very first thing we are going to do is, here first I can rewrite these equations as, here you have n plus 3 and I can write it as n plus 2 plus 1 and its whole power 4, plus we will write this expression as n plus 2 minus 1 and its whole power 4, and this whole expression is equals to 8. And after that you will see here we have n plus 2 be the common term, so that we will just take here y is equals to n plus 2. So when you can put y is equals to n plus 2, then this expression will becomes in the form of y plus 1 and its whole power 4, plus here you have y minus 1 and its whole power 4 is equal to 82. And now you can see here we have fourth power on both of the terms, and we can just write it as in the form of y plus 1 and its whole square and its whole power 2, because we can break this 4 and we write 2 to the power of 2, plus similarly we can write this expression as y minus 1 and its whole square and its whole power 2, and this whole is equals to 82. And after this step we can use here the nice square identity, and you know that if we have a plus b whole square, it is equals to a squared plus b squared plus 2 times of ab. And similarly you have you know about the negative formula, and it is equals to a squared plus b squared minus 2 times of ab. So here we will use these two formulas. So now first I can apply here this formula on the first expression, so that its first expression will be written as, here you have y plus 1 whole square and it will be equals to y square plus 1 square plus 2 times of y and its whole squared, plus similarly here you have y squared plus 1 squared minus 2 times of y and its whole square, and this whole expression is equals to 82. And after that I can again use here another triplet formula, and you know about this one. If we have a plus b plus c and its whole square, so it is equals to a squared plus b squared plus c squared plus 2 times of ab plus 2 times of bc plus 2 times of ca. And now we can use this formula on both of these terms. So now first I can apply this formula on the first term, and our first term will be written in the form of, here you have y squared and it will be equals to y to the power of 4 plus 1 plus 4 times of y square plus 2 times of ab, and the value of a is y square and b is 1, so it will becomes 2y square, and plus 2 times of bc, and b is 1 and c is 2y, so it is equals to 4y, and 2 times of ac, and a is y square, c is y, so it will becomes 4y cubed. And similarly we will open this formula here, and in this formula you will get here y to the power of 4 plus 1 plus 4y squared plus 2 times of ab, and it is equals to 2y square, and 2 times of bc, and b is positive and c is negative, so it will becomes minus 4y, and 2 times of ca, so it will becomes minus 4 y cubed, and this whole is equals to 82. And after this step you can see here some of the terms are cancelled and others are sum up by each other. So here you see that we have minus 4y cubed and this is plus 4y cubed are cancelled by each other, and this is minus 4y and plus 4y are also cancelled by each other. And now you have the remaining terms is y to the power of 4 and this is y to the power of 4. So it is equals to 2 times of y to the power of 4. And after that we have this is the 4, these are 2y square term and these are also 2y square term. So 4 plus 2 6y square and 6 plus 4 10y square and 10 plus 2 is equals to 12y square. And after that we have 1 plus 1 is equals to plus 2 and this whole is equals to 82. And now you can see that each term are divisible by 2, so that we can divide each term by 2 and you will get the remaining terms in the form of y to the power of 4 plus 6y squared plus 1, and here you get 2 4s are 8 and 2 1s are 2. So we move this 41 in the left hand side and you get minus 41 is equals to 0. And after that we will get here y to the power of 4 plus 6y squared and minus 40 is equals to 0. After this step you can see here this is the equation which is quadratic in y square. I can clear it. Here you write y to the power 4 as y square to the power whole square and plus 6y square minus 40 is equals to 0. And now in the next step we will just make the factors of this equation, so that the factors of this equation are y squared and its whole squared. We can write the 6y square as 10y square minus 4y square minus 40 is equals to 0, because here we need any two numbers whose product is minus 40 and whose sum is plus 6. So when you can multiply 10 by minus 4 you get minus 40, and when you can add here you get plus 6. So now we will take common y square from the first two terms and you get y squared plus 10, and we can take common here minus 4 and you will get here y squared plus 10 and this whole is equals to 0. And we will see here you can take common y squared plus 10 on both of the terms and you get y squared minus 4 is equals to 0. So here we have two cases. The first case is we can take y squared plus 10 is equal to 0, and the other case is we take y squared minus 4 is equals to 0. So here you get y squared is equals to 4 and y is equals to plus minus 2. Similarly in this case you will get here y squared is equals to minus 10, and when you can take the square root on both of the sides then you will get here plus minus 10 square root of iota, because here you have a negative sign under the square root and you know that it is equals to iota. So here we have again 4 cases. I can write each case separately here. So the first case is we have y is equals to square root of 10 iota. This is the first case. And the second case is we have y is equals to minus 10 square root iota. And the third case is we have y is equals to 2. And the last case is we have y is equals to minus 2. And in the start of the question we can take here y is equals to n plus 2. So now we back substitute the value of y, so that here you have y is equals to n plus 2 and this whole is equals to square root of 10 iota, and you can get here the value of n is equals to minus 10 plus square root of 10 iota. So this is the first root of the given question and this is the complex root. Similarly here you get n plus 2 is equals to minus 10 square root iota, and when we move this 2 on the right hand side then you get minus 2 times of minus 10 square root iota, and these are the second root which is also complex, and here you can put n plus 2 is equals to 2, and when we move this 2 on the right hand side, then you will get here n is equals to 0, and this is the third root. And when you can put the value of y here, then you get n plus 2 is equals to minus 2, and finally you get here n is equals to minus 4, and this is the fourth root of the given equation. And these are the all fourth roots of the given equation, in which two are complex and two are real, and this is the our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.